Physics Grade 10 Monthly Review Final Exam. Wave and vibration. Characteristics of a vibration. A vibration produces a wave with the same frequency, period, and amplitude. Define period. Period is simple as T. It is a constant interval of time a vibrating object takes place to make one vibration. Its unit is second. Frequency, its symbol is F, is the number of cycles a vibrating object takes place to make one vibration. Its unit is Hertz, Hz. F equal number of cycles over time taken. So F equal 1 over T. Amplitude, it is a maximum displacement of the vibrating object in either direction, measured from the equilibrium position. Amplitude A is equal to half distance between two extreme positions of vibrating object. Amplitude is here. Example. An object makes 30 vibrations in 5 seconds. Calculate T and F. 30 vibrations in 5 seconds. 1 vibration in periods. So T equal 5 times 1 over 30. So it's equal to 1 over 6 seconds. Now, 30 vibrations in 5 seconds. In 1 second, find frequency. F equal 1 times 30 over 5. So it's equal to 6 Hertz. Waves. It can be defined as successive traveling pulses or humps generated from a certain source of vibrations. Mechanical waves do not travel in vacuum. They need a material medium to propagate. Characteristics of a wave. Period, frequency, amplitude, wavelength, and speed of propagation. Wavelength. The distance between two consecutive crests or troughs. It travels during a period T of the vibrating source lambda in meter. Crest, from crest to crest, lambda. Okay. Or from trough to trough, also lambda. Speed of propagation. If V increased, then accelerated motion. If V decreased, decelerated motion. If V constant, uniform motion. D equal V times T. Distance is equal to velocity times time. In a homogeneous medium, traveling wave has a constant speed of propagation. Distance equals speed times time. The distance in wave is wavelength, which is lambda. Lambda equals V times D. Lambda equals V times D is equal to 1 over F. So lambda equals V over F. Lambda is in meter, V meter per second, T in second, and F in hertz. Transverse and longitudinal. Transverse wave. Direction of vibration of the particle of the medium. Direction of the propagation of wave. Direction of vibration is perpendicular to the direction of the wave. So, the definition is the direction of vibration of the particles of the medium is perpendicular to the direction of the propagation of the wave. Longitudinal wave. The direction of the vibration of the particles of the medium is parallel to that propagation of the wave. Direction of the particles is parallel to the direction of the wave. Electromagnetic wave. Electromagnetic waves produced by oscillating charge. They can propagate in both vacuums and other mediums. V equals C equals 3 times 10 power 8 meter per second. C equals lambda times F. Reflection of waves. A ray is a straight line perpendicular to wave front and following along their direction of travel. Lambda I, wavelength of incident wave. Fi, frequency of incident wave. Vi, speed of incident wave. Reflection of wave. Lambda I is the distance between two wave fronts. A ray of incident wave. This ray is reflected wave, and lambda r the distance between two wave fronts. In reflection waves, the incident and reflected waves have the same frequency, Fi equal Fr, wavelength, lambda I equal lambda r, and same speed, Vi equal Vr. Refraction. Refraction is the bending of wave when it passes from one transparent medium into another. Refraction of wave. Refraction of wave, the distance between two wavefronts is lambda I, and the distance between two wavefronts in second medium is lambda r. We notice that lambda I is greater than lambda r. In refraction of waves, the incident and refraction waves have the same frequencies but different wavelengths and speeds. Fi equal Fr, Vi different than Vr, lambda I different than lambda r. Note that V equal lambda times F, then F equal V over lambda. If N1 less than N2, then Vi greater than Vr. Lambda I, V equal lambda I Fi, Vr equal lambda R Fr. So, Vi equal greater than Vr, so lambda I Fi greater than lambda R Fr. But Fi equal Fr, so lambda I is greater than lambda R. Fi equal Fr, then Vi over lambda I equal Vr over lambda R. Question 1. A wagon of mass M1 equal 2.4 kg is displaced without friction along a horizontal table. M1 is connected to a mass of M2 by means of inextensible and massless string as seen in the figure. G equal 10 Newton per kilogram. Part A. Calculate in meter per second the speed of the wagon at A2. At A2, so V2 approximately V13 equal A1 A3 over T3 minus T1 equal A1, A3, distance from A1 to A3, so 1.4 plus 1.8, 3.2 centimeter multiplied by 10 power minus 2 meter. T3 minus T1, 2 tau. 2 times tau is 50 millisecond. 50 millisecond convert into second times 10 power minus 3 equal 0.32 meter per second. Now V3, it is V2 4 equal A2 A4 over T4 minus T2 equal A2 4 from 2 into 4 2 A2 into 4 A2 into 4, so 1.8 plus 2.2, it is 4 centimeter convert into meter times 10 power minus 2 over T4 minus T2, it is 2 tau. 2 times 50 times 10 power minus 3 equals 0.4 meter per second. V4, it is V3 5 equal A3 A5 over T5 minus T3 equal A3 A5, distance from A3 into A5, 2.2 plus 2.6, it is 4.8 times 10 power minus 2 over 2 tau. 2 times 50 times 10 power minus 3 equal 0.48 meter per second. V5, it's approximately V4 6 equal A4 A6 over T6 minus T4 equal A4 A6, it is A4 A6, it is 5.6 times 10 power minus 2 over 2 tau. 50 times 10 power minus 3 equal 0.56 meter per second. V6, approximately V5 7 equal A5 A7 over T7 minus T5 equal 6.4 times 10 power minus 2 over 2 times 50 times 10 power minus 3 equal 0.64 meter per second. B. Determine the acceleration of the wagon A3. A3 equal A24 equal V4 minus V2 over T4 minus T2 equal 0.48 minus 0.32 over 2 times 50 times 10 power minus 3 to tau equal 1.6 meter per second square. A4, it is A3 5 equal V5 minus V3 over T5 minus T3 equal 0.56 minus 0.4 over 2 times 50 times 10 power minus 3 equal 1.6 meter per second square. A5, it's approximately A4 6 equal V6 minus V4 over T6 minus T4 equal 0.64 minus 0.48 over 2 times 50 times 10 power minus 3 equal 1.6 meter per second square. Now deduce the nature of the motion. A3 equal A4 equal A5 equal 1.6 meter per second square. So A equal constant, then the motion is uniform accelerated rectilinear motion. C. The tension in the string is T equals 3.84 Newton. Represent the forces acting on M1 and M2. The forces acting on M1, tension, reaction, weight, W1, R1. The forces acting on M2, tension, T2, and weight, 2. Characterize the forces acting on mass M2. Part 2. Characteristic of weight. Point of application, line of action, direction, magnitude. Point of application, center of M2. Line of action, vertical. Direction, downward. Magnitude, W2 equal M2 times G. Its unit is in Newton. Now, T2. Point of application, line of action, direction, magnitude. Point of application, contact point. Line of action, vertical. Direction, upward. Magnitude, T2 in Newton. Part 3. Determine the magnitude of the resultant forces applied on the wagon. Summation of forces in the wagon, N1, T1, W1. Projection along a positive direction. So, F equal N1, 0, Q1, T, W1, 0. So, F equal T equals 3.84 Newton. For I, calculate the value of F over M1 equals 3.84 over M1 is 2.4, which is 1.6. Is Newton's second law verified? Yes, verified. Since F over M1 equal 1.6 equal also acceleration. So F equal mn. Newton applied. Part 4. Write the expression of the speed of the wagon as a function of t and v0. The motion is uniform accelerated rectilinear motion. So v equal at plus v0. V equal 1.6t plus v0, it's unit in meters per second.
Question 2. In figure 2, a mechanical wave is passing from medium 1 to medium 2. Part A. Name the phenomenon that a wave undergoes when it passes from one medium to another. This phenomenon is called refraction wave. Part B. How many complete waves are displayed in medium 1? Determine graphically the wavelength lambda 1 of the wave in medium 1. Part B. 5 waves and lambda equal 4 centimeter. Part C. Given that the speed of propagation of the given wave in medium 1 is velocity 1 equal 8 meter per second, determine the frequency f1 of this wave. Part C. Velocity 1 equal 8 meter per second. That's the given. Lambda equal v1 over f1. Therefore, f1 equal v1 over lambda 1 equal 8 over 4 times 10 to the power minus 2 equal 200 hertz. D. Determine graphically the wavelength lambda 2 of the wave in medium 2. What can be said about frequency f2 of the wave in medium 2? Deduce the speed of propagation v2 in medium 2. The wavelength is from crest till crest. Lambda 2 equal 2 centimeter. Frequency 2 equal frequency 1 equal 200 hertz. It's the same frequency. Since frequency does not change in reflection and diffraction. Then V1 over lambda 1 equal V2 over lambda 2. Therefore, 8 over 4 equal V2 over 2. Then V2 equal 8 times 2 over 4 equal 4 meter per second. Question 3. A car of mass equal 1200 kg starts from rest on a horizontal road on a uniformly accelerated rectilinear motion and attains a speed of 36 km per hour in 5 seconds. The force which opposes the displacement is equivalent to a constant force parallel to the line of motion of magnitude F equal to 140 Newton. Part A. Calculate the acceleration of motion and the distance traveled. To find the acceleration, V equal AT plus V0 initial speed, which is 0. Then A equal V over T equal 10 over 5 equal 2 meter per second squared. Now we should find x. X equal half at squared plus v0t plus x0. That's 0 and this is 0 too. Half times 2 times 5 squared equals 25 meters. Part B. Represent on a figure the forces acting on the car. That's along positive direction. Suppose this is the car. We have weight, force, friction. We have the normal, which is the reaction of support, and the force F. Part C. Applying Newton's second law, calculate the motor's traction force. Apply Newton's second law. Summation of forces equal mass times acceleration. Then weight force plus Newton plus normal force plus force plus friction equal mass times acceleration. projection along positive direction 0 plus 0 plus f minus friction equal ma. Then f equal ma plus f equal to 1200 times 2 plus 340 equal 2640 meters. Part D. Calculate the force of traction of the motor when the movement of the car is uniform rectilinear motion. Uniform rectilinear motion. Therefore, A equals 0, then weight force plus normal force plus force plus friction equal mass times acceleration. Projection along positive direction, then 0 plus 0 plus f minus f equal ma. F minus 240 equal 1200 times 0, then F equal 200 Newton.
On an airtable inclined by an angle A with respect to the horizontal, we launch from top and without initial speed a puck. The puck describes rectilinear motion along the line of greatest slope on the table. We neglect friction. A. Represent on a figure the forces acting on the puck. So we draw an inclined surface and we draw the puck. Then we have weight and we have the normal reaction of a support. And after projection along positive direction, we have W becomes Wx. Okay, now number 2, or B. Apply Newton's second law. Show that the acceleration of the puck is given by A, G sine alpha, where G is the gravitational acceleration. So the summation of force F equal ma. W plus m equal ma. And projection along positive direction. We have Wx plus 0 equal ma. Mg sine x or alpha equal ma. A equal G sine alpha. Part C. Specify the nature of motion of the puck. Since the acceleration is constant and A is greater than 0 meter per second squared, then the motion is uniform accelerated rectilinear motion. Part D. Knowing that the puck covers a distance of 23.2 centimeters in 0.5 seconds, calculate A and deduce the value of alpha. So x equal 23.2 centimeters times 10 power minus 2 equals 0.232 meters. The time is equal to 0.5 seconds. We need to calculate A and alpha. Since the motion is uniform accelerated rectilinear motion, then x equal 1 over 2 at squared plus v0t plus x0. This is 0 and this is 0. So 0.232 equal 1 over 2 a times 0.5 squared. A equal 0.232 times 2 over 0.52, which gives us 1.856 meter per second squared. A equals 0.232 times 2 over 0.25, gives us 1.856 meter per second squared. A equal G times sine x, sine alpha. Sine alpha equal A over G equal 1.856 over 9.81. Then alpha equal sine minus 1.856 over 9.81, which is approximately equal to 11 degrees.